We're going to learn about 3 new theorems today. So this is ASA, AAS, and HL congruence. And we are going to prove that triangles are congruent using those 3 theorems. Okay, so first one we're talking about ASA, that's angle, side, angle congruence. If 2 angles and the included side of one triangle are congruent to 2 angles and the included side of another triangle, then the triangles have to be congruent. So here's what we're talking about. A and D, notice those are angles. So if angle A is congruent to angle D, and then side AB and DE, AB congruent to DE, and then if you have another pair of angles, so angle B and angle E. So notice that side has to be between those 2 angles or it doesn't work, has to be in that order. Then you can say the 2 triangles are congruent. So triangle ABC be congruent to triangle DEF. So once again, this is a shortcut theorem, so you don't have to show that all 3 sides are congruent, all 3 angles are congruent. You can just show an angle, a side in between, and another angle. Okay, so let's do our proof. So, first thing we're going to do is we got this given statement, and that is statement number 1. And that is the end of our given. So from now on, it has to be vocabulary or a property, something like that. So this one says RQS is congruent to TQS. So right here. Notice that we used one of our vocabulary words, and that was bisecting an angle. So I'm going to say this one is, well, let me say definition of angle bisector. And just to be lazy, I'm going to put DEF. So definition of angle bisector. So we took care of this one, but we haven't taken care of this next one, which is our next statement. So RSQ over here is congruent to TSQ, but again, that's the definition of an angle bisector. And then they say that QS is congruent to QS because they're sharing the same side. Remember, if it's just the same side repeated, that is your reflexive property. So notice what you've done on the picture. You have a pair of angles, a side in between, and a pair of angles. So that is your side, angle, side theorem. Oh, what? No, that was embarrassing. Forget that happened. That is my angle, side, angle theorem. Ooh, okay. So A stands for angle, S stands for side. Apparently, I needed that lesson. Okay. So let's move on and do another. So first thing, super easy, we're going to state the givens, and there's 2 different givens. Well, there's one given, but there's like 2 things going on. So it says that JK is parallel to LM, and then it also says JL is parallel to KM. So we're talking about parallel lines. So we're going to be using those 8 different angles that you can form. So we can look for, anytime we state parallel lines, we're either looking for alternate interior, same side interior, alternate exterior, or corresponding. So when you look at statement 2 and 3, I want you to pause the video and I want you to see if you can pick out the pair of angles in statement 2 and angle 3. Are they alternate interior, same side interior, corresponding, or alternate exterior? So try that in 1, 2, 3. Alright, so when you look at JKL right here and MLK, those are alternate interior angles. Okay, and then if you look at JLK and MKL, also alternate interior angles. So hopefully that's what you picked. And I'm going to switch colors. And then we have KL is congruent to LK. So they're sharing that side, but it's a mirror image. So this is the symmetric property, but we have stated we have a pair of angles and a side in between and another pair of angles, so angle, side, angle theorem. Okay, so I want you to pause the video and I want you to see what you can come up with. You can at least come up with the statements that are given to us and that being a reason, and then maybe you'll recognize that you're using a vocabulary word, hint, hint, hint. So that next statement needs to be using that vocabulary word. So pause the video and try it. 1, 2, 3. Okay, so hopefully you at least got to this point, because that's just basic reprinting what's already in there. So if I use the word midpoint, I know that my next reason needs to be definition of midpoint. And we know that a midpoint is going to be directly in the middle of AE. So that means that these two sides have to be congruent. So that's my next statement. So side AC is congruent to CE. That's a D. Can't spell E. And once again, I'm using the definition of midpoint. And then these two angles, if you'll notice, they are vertical angles, because they're two intersected lines and they're right across from each other. So now we're just going to state that. So BCA is congruent to DCE because they're vertical angles. And now we have enough to use the angle side angle theorem. And remember, your last statement needs to be exactly what it said to prove. Alright, so that's how you write a proof for that one. So now let's look at the angle side theorem, so AAS. It's pretty much the same theorem that we just talked about. The side is in a different location is the only thing. So if you have angle A and angle D congruent, and you have angle B and angle E congruent, and then you have a side that is not in between. So BC is congruent to EF. Then you can state the two triangles are congruent. So the only difference between this theorem and the one we just talked about is the location of the side. So non-included means a side opposite the angles, not in between them. Alright, so I want you to pause the video and I want you to come up with some statements and reasons. You don't have to come up with all of them, but there's some givens, and then hopefully you can see some other stuff. So try the video. 1, 2, 3. Okay, so if you put those two right together, that is perfectly fine. You did nothing wrong. I just separated them because the first statement says the word bisect, and you're bisecting an angle. So I know that I want to make a statement with the reason definition of angle bisector. So if you state it, you have to use it. So that's what I'm going to do. So if it is bisecting angle WYZ, that means angle WYZ is congruent to angle XYZ. WYZ is congruent to angle XYZ. So that's what that means. And then maybe you saw that they were sharing this side. So your statement is going to be determined by how you write this. If you write it like this, that's your reflexive property. Or, remember, if you write this where it's a mirror image, that's your symmetric property. So it really just depends on whatever you wanted to write. So the last prove statement should be what it gave you in the beginning. We have enough information to prove this because we have a side, another pair of sides, an angle not in between. So that's my angle side theorem. Okay, let's do another one. So I want you to pause the video and I want you to come up with as many statements and reasons as you can. If you can do the whole thing, awesome. If not, it's okay. Play the video and we'll go through it. But you just try whatever you can do. So try in 1, 2, 3. Alright, so here's how I set it up. If you put them all three together, it's exactly the same thing. So if I am using the fact that I have parallel lines, then I need to be looking for the angles that parallel lines make. So I need to be looking for alternate interior, same side interior, alternate exterior, or corresponding. I see right here, let me do it in orange, that I actually have corresponding angles. If that doesn't make sense, go watch that video again to see what corresponding angles look like. But I can state that angle BAC is congruent to angle ECD because they're corresponding angles. And then if I know that C is the midpoint, I know that I'm going to use the definition of midpoint, and my next statement is going to be that these two sides are congruent. So AC is congruent to CD. And now I have used enough information to use angle, angle, side. And then my last proof statement needs to be triangle ABD is congruent to triangle CBD. So if you got that all right, awesome. You're an all-star, because this is way harder than it actually seems. If you're having a little trouble, it's okay. Just don't give up. Keep pushing through. Alright, so I want you to pause the video. I want you to write as many statements as you can think of and reasons. Make sure you're color coding or at least marking on the picture like I am, because I swear that helps. So you try it. 1, 2, 3. Okay, so these are the statements. They are color coded. If for some reason some of this doesn't make sense, let me know. But we use the angle, angle, side theorem because that's what we have on our picture. So hopefully you're getting these. They're a little difficult, so if you're not, it's okay. Just take a deep breath. We're good. All right. So I always get asked in class if there is an ASS theorem. It's a bad word. No. So there's no ASS theorem, but there is an HL theorem, which, if you look closely, it really is the ASS theorem. But we don't call it that. We call it the HL theorem, and it only works on right triangles. So here we go. If the hypotenuse, which is the longest side, and the leg of a right triangle is congruent to the hypotenuse and leg of another triangle, then the two triangles are congruent. Hence the reason it's called HL theorem. Okay, so if I have my hypotenuses congruent, so BC is congruent to EF, and another leg, it doesn't matter which one, so AB is congruent to ED, or DE, whichever one you want to call that. And they do have to be right triangles, or you cannot use this theorem. Then you can say the two triangles are congruent to each other. Alright, so this is what we're looking for in order to conclude two right triangles are congruent. They have to be right triangles, you have to have the hypotenuses, and you have to have a pair of sides. Okay, so I want you to pause the video, and I want you to write the givens, and then mark them on your paper, and then we'll talk about them. If you think you can finish this whole proof, go ahead and do it. 1, 2, 3. Okay, so right now you know that there are two right triangles. You know that the hypotenuses are congruent. You need a pair of legs, and then, so here's your pair of legs, and that is your reflexive property because it's the same thing on both sides. Alright, so you have stated enough to use the HL theorem. So the two triangles are congruent using the HL theorem. These are pretty easy problems, I think. Alright, I want you to try this one. I want you to see if you can do the whole thing. Remember, we have to prove that they're right triangles, that their hypotenuses are congruent, and a pair of legs. If you have that, then you have enough. Alright, I see some vocabulary words in here. Hint, hint, hint. So one of our statements is going to be definition of midpoint. See if you can do this all the way through. Try it. 1, 2, 3. Alright, so here it is. You can look at it. I tried to color code it a little bit. The only one that took a little brain power, and I didn't mark it on here, my bad, was the one in purple, statement 4 and reason 4. But you're using the definition of midpoint. I think that HL is kind of the easiest of all of them, but you may be different from me. Let me know if you have any questions, and I'll try to answer as much as I can.